Hello, I'm Shalimar Elkridge. Today we're doing Stata 8 on pooled data. Without further ado, let's get started. What is our research question today? Our research question today is what factors contribute to the price of a home? The variables that we'll be looking at to determine what factors contribute to the price of a home are the price it was sold for, the living area, the PR age, the beds, the baths, the lot area, and the month in which it is sold. The month in which it is sold is a binary variable, which month one is for January, month two is for February, and month three is for March. Here we have the number of observations, the mean of each of these variables. Well, for the mean of the sales month, that is pretty much uninterpretable as this is a binary variable, which we can see from the minimum and the maximum being a 0 and a 1. The mean kind of doesn't really mean anything. It can kind of show you which way maybe the data is skewed, but not necessarily interpretable. And we have the means and the max of the rest of our variables as well as the standard deviation. And yeah, without further ado, let's dive a little deeper into the data. For our Y variable, we'll be using the sold price, which is the price in which the house is sold, as this is what we are looking to see what factors contribute to this. And for our X variables, we will be using living area, the PR age, the lot area, and the month in which it is sold. As you can see for our test for multicollinearity, not the VIF necessarily, but the correlation matrix shows that beds and baths are highly correlated with not only each other, but are highly correlated with other variables in our data set. So we're going to go ahead and drop those to alleviate the multicollinearity within the data. After that, we moved on to testing for heteroscedasticity and nonlinearity. The heteroscedasticity tests that we use, there are three that we can use, which is the White test, the Bruce, Pagan, Cook, Weisberg test, and the LM test. If two of the three agree, you're able to proceed with those results. So the two I included are the White's test and the Bruce, Pagan, Cook, Weisberg test, which both show we should reject our null hypothesis, which is that there is homoscedasticity, and accept the alternative hypothesis that we have heteroscedasticity. From there, we're going to want to solve this. So we're going to run some K-density graphs to see how they are distributed over a normal distribution. So we ran those for all of our variables, and I found that, you know, there's some of them that should be transformed one way, there are some that shouldn't be transformed that way. And we also run the NL check to see if a polynomial may fit better with the data. From there, we were determined this final regression that we should transform living area into a polynomial. We should transform the PRH into a polynomial, and we should transform lot area into a natural log in order to alleviate the data of the heteroscedasticity. When checking for K density, we determined that natural log fit in lot area the best. So I proceeded on with that transformation in order to better fit the data. And we also included sales month in our final regression, as this must be included to show time fixed results. Comma robust relieves us of that heteroscedasticity as well. And now let's interpret our coefficients. Since all of our variables are nonlinear, we are not able to directly interpret the coefficients without plugging in results. Our adjusted R squared is 55, is 0.552, which says we are encapsulating about 55% of what actually determines home price in our current regression. This regression gave me the highest R squared based on other transformations and other forms of the regression that were ran. So this is the regression I decided to finalize and go with. I hope I answered all your questions thoroughly, and I thank you very much for your time. Thank you. Have a great day.